Yeah, so I know how many people are on YouTube. Hi. Yeah, so I see there's just two people on Zoom so far. I'm not sure if we were starting at 10 past or now. So if you I guess if you're on YouTube, I have no way of seeing you. So like if you could say that you are there on Discord so that we know that there is a point to starting, that would be good. Oh, yeah, so let's yeah, okay. I think there's still kind of more people showing up. So I think what we should do is we should wait until 10 past 12 because I think maybe most people assume that it's that. If people want something to do, so I just posted the 2023 exam. So I'm gonna go over some of the questions during the session, but at the same time, like I always say, it's actually a lot more valuable to do those yourself. So maybe you should try doing the first couple of questions of the exam by yourself. The Zoom link. So it's like the usual Zoom link. Yeah, so if you just joined, we're waiting for 10 past to see if more people don't show up as they keep doing. So yeah, good. So we're waiting until 10 past 12. All right. Hi to everyone from the West Coast. It's warm but rainy. So which I imagine not that different in Toronto either. Okay. So what I want to do today is kind of focus more specifically on what you need to do if you feel like you really need to substantially catch up. For example, if your performance on the midterm was kind of not what you would have hoped for, and your hopes initially weren't like 97 and you got a 95, this session would not be useful for you if that's the case. So the way I want to do it is first, so I want to just recommend the basic exercises that I just posted on Piazza. So those could be useful. Again, I don't actually recommend that you pay the $25. If you want to pay that, you're absolutely welcome to, but you get the exercises for free anyway. You just don't get to try them on the web interface, which I think might not be good anyways. I think it probably is better if you actually work in the IDE, whether you check them or not. And if you do work in the IDE, I think coming up with test cases and making sure that your code passes your test cases is actually itself good for practicing. So that's how I recommend approaching it. And those exercises, like, they're all pretty short, so you really should kind of keep practicing until you're at a point where it feels like it's easy for you to do that stuff. So that's one thing. So the other thing that I want to do is kind of go through the first several questions on last year's exam. So that's here. That's also linked from the course webpage. And just kind of like, I'll solve them and I'll try to analyze, okay, like, here are the things that you need in order to solve this problem and this problem and this problem, right? So, of course, kind of, it's not always the case that exactly the same things are needed for exactly the same questions year to year. In fact, it's usually not the case. And the more correct way of thinking about things is that you're getting kind of the holistic skill of getting things to work, as opposed to like, I'm learning, like how to do a for loop, how to do a while loop, and so on. In fact, I think people who think that way, who think, okay, like, let me just learn how to do a for loop, let me just learn how to do a while loop, I think there are very real limitations to where you can get with that kind of approach, because it's actually like, it's not difficult in isolation to memorize, okay, this is how you do a for loop, this is how you do a while loop. But I'm not going to ask you in the exam, how do you do a for loop? I'm going to ask you, here's a problem, you need to solve it. And in order to solve a problem, even a simple one, you need not just to know how to do a for loop, you need to know how to apply for loops in a flexible kind of way. And this, I think, doesn't really work well if you kind of really compartmentalize it and say, okay, like, I'll just learn about for loops, learn about while loops, and so on. With that said, different people have, different styles. And for some people, just in your mind, compartmentalizing it might work. I don't know. So this one is not going to be very difficult, I think. So this is a question that asks you to return the factorial of n. So here's one way you can do it. You'll just keep multiplying result by I. And you'll return result eventually. So what are the things here to pay attention to? So one, I guess I'll call out the constructions explicitly, and I think it might be useful as you're going over other exercises, maybe, or like other past exams and stuff. It might be useful for some people to kind of explicitly call out what the techniques are here, right? So one technique is and go through 1, 2, 3, and so on, and use them using a for loop. So this is a little bit atypical, right? Because usually what this guy means is just repeat n times. Here, yeah, we're repeating it 10 times, but we're actually using the I inside the loop, right? So here we're saying result times 1, and then result equals result times 2, and so on. So that's the kind of thing that you can do. By the way, kind of ask me questions anytime you want. You can just, I think there's like just 14 people on the call, so you can just like unmute yourself and ask anytime, or you can raise your hand if you like. Let me actually find the chat. There's nothing in the chat right now. I have received a new emoji. Okay. That was a lie. I'm not. Okay. All right. So that's one technique. So the other technique is accumulate the results in the variable, updating the variable during the computation. And that's like, again, like an extremely common thing that you see. You might not even say that it's kind of like an unusual thing, but here what you're doing, so res starts out as 1, and then you keep multiplying it. And finally, we need to know that res needs to be a double. Because the factorial is very large. I don't think we deducted points if you didn't make it. Oops. I don't think we deducted points if you did make it an int. Of course, kind of the requirement in the paper itself is that it should return a double. So if it returns a double, but you are, saying it's an int here, of course, that wouldn't work. It's not ideal. I don't think we deducted points for not doing that. Okay. So what is the runtime complexity for the function that you wrote? Of course, this would depend on the function. In this case, it's pretty easy because what's happening here is we're doing multiplications with doubles. So doubles are fixed width. You might worry that with ints, it's a little bit different, but doubles are fixed width. So multiplying double by anything, that's fixed. So ints, of course, and C are fixed as well. So as for the complexity, well, so no, not really the case for C, because in C ints are fixed width as well, right? So it would be all of n either way. So the complexity is we have so we have kind of everything is proportional to n. So each of the operations takes constant time. So okay. So that's that. So complexity is so yeah, I expect that actually like maybe some people, especially if they struggle in 190, maybe kind of complexity in 180 needs to be reviewed. So so far what we've done as far as computational complexity in 190 is technically we did some quite advanced analysis in the first lecture that was just a continuation of 180. In fact, it was like the solution of the 180 exam. Since then, up until very recently, I think the complexity analysis was basically on this level. We haven't really done anything that's kind of beyond this. So in the coming weeks, there might be more of this. So if you have time, in kind of before Thursday, I would kind of strongly recommend reviewing the complexity stuff from 180, both because we've already technically covered it in 190, because we kind of did the more complicated questions from the 180 exam in 190, so as part of the material, and because there's going to be more of that later on. Yeah. So, okay. So that's like that. So here, write the function which takes in a string, replaces every occurrence of winter with summer, right? So this is about, kind of stuff that's quite similar to, I think, lab 2 probably, maybe lab 3, where we were operating on strings. So to quickly review, yeah. So blocks of cars, right? So for example, yes, now terminated. So for example, if car S is hello, then that's the same as S. So it's kind of like separate cars, and then at the end you have a null. Right? So what we want to write is basically we have, so it's basically like a 180 problem, plus you need to know how cars work in C, right? In the sense that they end with an L, not really in any other sense. So if you find that this is challenging, I think one way to do it, and this is how I'll start, is to actually write it first in Python. And in Python, it's not going to be actually super straightforward if I do it with strings, because strings in C are more like lists in Python, right? So what I'm thinking is kind of like this. Yeah, you could do it like that as well, of course, but that would not do you much good if you are trying to do something in C. So the way I'll do it is I'll say, okay, like L, and I'll do it as a list. So because I was hoping that it would auto-complete it. Hold on, I think if I copy it over here, it will. Guess not. Okay, I'll do it manually then. So this is the kind of thing that they need. Sorry, just one sec. I'll just make it reasonable. Oh. What's the problem? Oh. Okay, that is what I meant. So if it's kind of like this, then I want to call replace WL, and then I want to replace winter with summer, right? So something like this. So how would I, and of course, kind of on the exam, you would not need to like actually do it. It's just kind of, maybe it's helpful to think about it as how would it be in Python. So one way to do it is to just go through L and then see if at the current location, winter matches. And if it does, then replace it with summer, right? So I'll write it kind of a little bit Python-y. So I'll say for start I in range length of S -5. And I'll compare S starting at I, start I plus 6. So this would be potentially winter, right? So potentially this guy. And I'll just compare it. Is it actually winter? So compare this to this. And if it is, I'll just replace all the stuff over here with summer. So I set it up so that I could set it up to be more difficult, where it doesn't have to be that winter and summer actually have the same number of characters. In Python, that wouldn't be more difficult. In C, it might be a little bit more difficult to do it. In this case, I set it up so that it's not the case. So that's everything that you need to do, right? So if you can kind of do it in Python this way, then, and again, kind of if you're trying to work with strings, but pretend that you're in Python, you should really be thinking about it as you're working with lists. So and that's because lists you can modify. So you can do this kind of thing with lists. It's not something that you can do with strings, right? So if you got that ready, then you can probably translate this into C now. So let me do this. So this is car S. And I'll do kind of the same thing, right? So I'll say, I'll use start I. And I'll say for whatever, start I goes 0, and then start I is smaller than strlen S -5. By the way, so in Python, that was not necessary. You could go until the end. It's just that it would be cut off and it would never be equal to winter if start I is too large, but that's fine. And then I'm just asking, do I need to replace it at start I? Do I need to replace it at start I plus 1? And so on. So how do I know whether start I up to start I plus 6 is the same as winter? So there is actually kind of a shorthand here, which is what Copilot is trying to do. So if you're working with strings, you can use str and cmp and just say, compare this as if this were a string that's of length 6 to this string winter, and it'll return 0 if they're the same, and it'll return something that's not 0 if they're not the same. So you can do it using str and CMP, where you supply the 6. You cannot do it with the str CMP, because str CMP assumes that both the input and the output have the same are valid strings. And s plus start I, it is a valid string, but it's a valid string that ends at the end of s. It doesn't necessarily have the length 6, right? So this is definitely a valid way to do it, but let's say that I don't remember about STRs and CMP. It was on the handout for the midterm as well. But anyway, let's say that you don't know about it. What would you do? Well, you would have to basically do this, but manual, right? So this is kind of going back to lab 5 from 180, where we had a similar example with match pattern, maybe match 6. Yeah, the handout would be the same as for the midterm, basically. So I'll just say kind of match pattern. And it would be car S, and it would be car pattern. And there would be, so that would be this. And we'll say, assume that S is at least as long as pattern, so that we don't have to worry about going over S. So what can we do? So I can basically say this, right? So I'm starting with I, and I'm going, well, I don't really want to, well, sure. So we're starting with pattern 0, pattern 1, pattern 2, and we're asking, is S0 equals to pattern 0? Is S1 equal to pattern 1? And so on. And I'm saying, okay, if there is not a match at any point, then there is no match. And then if at the end there was a match, that there wasn't not a, so we never find a mismatch, then we return 1. So with the match pattern, what you can do is you could say, okay, so if we match and there's going to be its pattern. So basically what I'm doing is I'm saying, okay, so for the string that starts at S plus start I, right? So that is basically if the string is like this, so S plus 0 is just the entire thing, and then S plus 1 is this string, and then S plus 3, for example, would be just this string. Right? And I'm saying if just this string matches the pattern in the first 6 characters, then there is a match. And here, what Copilot suggests, and I'll take the suggestion, is it just says copy summer. Well, actually, let me not take the suggestion. So copy summer into S plus start I, right? So let me do it inside of here. Yeah, I can even do it like literally like this. Right, so I'm just replacing the W with S, the I with U, and so on, if I see that there is a match. All right, so in terms of what you need for this, So again, like this is kind of in terms of algorithmic development, this is really kind of stuff that we've started developing in 180, right? So just basically operating on lists and kind of, for example, matching patterns on a list. It's like just a problem that you can solve with a loop, right? In addition, you need some facility with being able to use C strings. So you need to know that C strings are now terminated. So here we're using this information implicitly. So in order to find the length of pattern, you need strlen needs to go through the pattern and find the null. Otherwise, you just need to understand that strings in C are just blocks of memory, blocks of cars, and you can operate on them basically in the same way that you can operate on lists in Python in this kind of context where all you need to do is like match information to them and possibly modify individual elements. All right. So, okay. So this is this one. So this is one of those things which is maybe kind of, I would say, like is like more an intermediate question. Like anything that's involving recursion is usually a little bit more difficult. But at the same time, this question is quite similar to a number of questions that we had in the labs where we wanted to use recursion to operate on those kinds of either strings or things that are like strings. So in this case, the arrays are actually arrays of integers rather than arrays of cars, work the same way. The only difference is they don't have a null terminator, right? So write a recursive function that compares two blocks of integers, returns 1 if they're equal and 0 if they're not equal. So basically strcmp, except for arrays of ints. And here it was like a little bit, I don't know. So I said the name of the function as well, the function's signature. So what parameters are up to you, right? So the idea here, and here we said you may not use any helper functions, not because there are any super useful helper functions here, but just so that people are not misled into thinking that there is something like strlen for things that are not strings. There just isn't. So what do you need to, so first of all, I think the way I'll do this one is I'll first do the solution and then I'll talk about what I think you needed for that, right? So what was it called? It was called, oh, it wasn't called anything because you were supposed to come up with a name as well. So I'll name it compare blocks. So just once you figured out that you need the size, all you need to say is, okay, like go through every element. And if the elements don't match, then we're returning a 0. And then at the end, if there was no mismatch, we return 1. So actually quite similar to what we've done. So kind of a lot of it was just like basically understanding how arrays work in C, in the sense that there are blocks of elements. They don't actually store the length. So you have to give the length to the actually, so was it, oh, they could be different lengths. So it should be actually like we call it A1 and A2 and N1 and N2. And here, like if they're different lengths, they're definitely not the same. And then if I haven't returned 0, now I'll go through one of them. So at this point, n1 is definitely equal to n2. So I can do either, right? n1 and n2 are the same. And then if the lengths are the same, but there is a mismatch, again, it returns 0. If n1 does not equal n2 did not trigger, and then this never triggered, that means that they're the same. So what you need to know, again, you need to know that the way you access a tie is this way. You need to know that in order to compare two arrays, what you need to do is you need to compare individual elements, because of course they can have the same contents but be stored in different places. So you kind of just say like A1 equals A2. That would just literally compare, are they literally the same array that's stored at the same location? And you need to know that, okay, like I need the size, so it's got to mean that I have to pass the size to the function. So int n1, int n2 have to be part of the function signature. All right. So that is this. Oh, sorry. So I wrote it, I actually wrote it iteratively. I forgot I was writing a recursive function. So, but that's good. So we wrote it iteratively. So now let me write it recursively. But kind of, it's a good exercise to write it iteratively as well. So again, it has to be that the sizes are the same. And what we'll say is, again, like if n1 is not equal to n2, the answer is definitely 0. And then what's another easy base case? Well, if they are of, so if n1 is of length 0 at this point, that must mean that n1 is equal to n2 as well. So we can just say, okay, that matched. At the same time, I think Copilot's suggestion is right. So we'll say that it's never going to be the case that we send in lists of length 0, because then it wouldn't really make sense. Like this wouldn't even be a valid address. So we'll say if n1 is equal to 0, then we return 1, and that will make sense later on. So now we need to think about the recursive case, right? So let's say that you're comparing like 1 to 4 and 1 to 3. So what we can do is we can say, okay, if the first two elements are not the same, then we know that the lists are not the same. On the other hand, if the first two elements are the same, we can say, okay, like we'll just check the rest. So we'll check, is 2, 4 the same as 2, 3? And here 2 and 2 are the same. So we can't right away say that they're different, but we can say, okay, then we'll compare 3 and 4. And at that point, we'll return false. So the trick here, it's kind of the same as what I did in the last question, where if you know the address of the 1, you also know the address of the 2, because you can just do A1 plus 1, and A1 plus 1 would be the location of the 2. Right. So what we'll do now is we'll compare A1 at 0 to A2 at 0. And if they're not the same, we return 0. So now, if they're the same, then what we'll do is we'll do the recursive step, which is so like if we started out with A1 being this and A2 being this, we'll make A1 be 2, 4 by sending A1 plus 1 to A1, and the same with A2. And now that instead of comparing 1 to 4 and 1 to 3, we're comparing 2 and 4, what we're doing is we're reducing n1 by 1 and n2 by 1. Okay, So what do you need to know for this kind of thing? So I would say that this question is actually quite similar to, I don't remember if this year we had done STRCMP in lecture and STRCPY in lab, or the other way around, but one of those, and we did it both iteratively and recursively. And this is basically the recursive STRCMP. The only difference is that for STRCMP, you have a different way of indicating that the string is now empty. So you just look and see whether it starts with a null. With arrays of integers, you cannot do that because they're not null terminated. So what you would have to do is you would also have to pass the size of the arrays that you're comparing. So there's a question in the chat. So if we didn't know how to write the code, but wrote out a detailed explanation in some attempted code, would you get significant part marks for that? This is not really a question that they can answer in general, just because it really depends like what the sum attempt was. So in general, the policy in 180, 190, same as on the midterm, and that's what it says on the front page, is that you can write comments in English, but we will not grade them directly, right? So what we can use the comments for is to understand your framework, right? So it might help us understand better the code that you write. We actually grade the code. So ideally, it would be the case that code that's a partial solution without comments would get the same as code with an explanation. Now, in practice, I think it might be that if you explain your thinking better to a TA, on average, that will help you rather than hurt you. It could also theoretically hurt you, right? So it could be that you write down a partial solution, and in the TA's imagination, that they kind of see, oh, that's extremely close because the TA knows how to get that solution to the final destination. But if you don't know exactly, then actually like you're revealing that you don't actually know exactly what the correct plan is, and your partial solution is not actually like on the way to being the solution, that might theoretically hurt you. But that's like the practicality of it, right? So ideally, we don't mark comments, we just mark the code, and it shouldn't matter. In practice, it could, and it would probably help you rather than hurt you most of the time. But the reasoning behind making it be like this is that we really, really don't want it to be a situation that people like write out long essays of like things that they might try. Like if you have time for that, well, like just try. For this type of problem, are there any limitations on the input parameters? No, like, so it said like you write whatever function signature you want. So the only limitation would be that you're writing code that's supposed to be valid C code without including any extra libraries and stuff. All right. All right, I'll check Discord. Discord is not saying anything. Okay, all right. So this is actually like, yeah, okay, let's do this. So write a function that inserts a node with value new value at index I. So basically, it gives you a linked list structure that's similar or identical to what you've seen in lecture, and it asks you to implement one of the kind of standard functions. So this is insert. No, this says append. Yeah, but it is insert and here, so just named append. Okay, we fixed it during the exam, I guess. And we said, so if you're inserting 42 at index 1, then the usual thing, it should be that the new element at index 1 is equal to 42. So that's kind of like the usual thing, and kind of linked list is an extremely kind of like something that we spent, a fair amount on. So this is the kind of stuff that, yeah, like you can actually just practice, like all there is for linked list basically is like, like length, insert, append, delete, stuff like that. I'm not saying it's going to be on the exam, but it has been in the past. And like the only kinds of variations for that, so I can try to make up like a new function that's not a standard function, but that's kind of similar to standard functions, or I can try to like vary, like the structure of like the structs exactly, although there's not much room there for for changes. So like the only thing I can do is like, like if someone like literally memorized something verbatim without understanding it, and like, I don't know, I change like next to following or whatever, uh, or like something to that effect. There's not a lot of substantive stuff to change there. The only substantive thing that you can have is you can have a separate head, or you could just store the entire linked list by storing the node, the first node, right? So the difference is, so if we store the linked list, right? And if we store the linked list, right? So it's kind of a question of like, are you setting like the main thing that's storing the list to null if it's empty? Or do you have like a special head inside LL, which you do set to null if it's empty, but the outer thing itself is still a valid variable. That's not null, right? So that's like a variation. So here, what we want to do is we want to insert into my list. So what should we do? So we create a new node. Good idea. So the data in that node is going to be the new value. Next, for now, we'll set to null. It's going to change. And now we have kind of the two options. So one is that we are inserting at the beginning. So the head should become new node, right? So new node next is the old head. And the new head is the new node that we just made. Otherwise, we need to walk through the list until we find the node after which we're inserting. So we'll just keep updating current. And note that this is assuming right. Well, like really, yeah. So, okay. And now we do kind of the surgery. I'm not going to do the pictures now, but you can go back to that lecture. So I'm saying new node next is the next of the thing after which we're inserting, because so we had kind of like, so kind of the structure that we intend at the end is like current and then new node and then the current next, right? So new node next is going to be current next, and then current next is going to be new node. And we're done. Okay, so what did we need to do here? So we needed to know how to create a new object of type. So we needed to know that we need a new node in memory that's actually going to store the data. So to create a new object of type node, that's like this. So this is the usual thing. You need to know that if you're creating things like this, and you must create it like this. If it's a local variable, then it will go away after the function finishes running. So you need to malloc it and store the address. And then if you are trying to edit the fields of an object, that's the arrow operator. And then you needed to remember basically kind of how you operate with linked lists. So for example, how you walk through the nodes. So there is already a recording of that. So I'm not going to repeat how to do that, but it's kind of like this. Okay. So this is the kind of stuff where, I imagine that some people maybe are not super comfortable with it. And really, this is one of those things where it's not exactly problem solving in the sense that linked lists are like an extremely, extremely common thing. So in the King textbook, there is a whole chapter specifically about linked list, even though it's kind of like you're implementing it. It's not as if it's part of a C programming language. It's like something that you build on top of the programming language, right? But nevertheless, it's like an extremely common thing. So like if you feel like you need, like you might benefit from like an explanation in text. So this is also in the lecture notes, but also there is a whole chapter in the textbook with code as well. So look at that. And then just, like with this, I would say, yeah, like whether it's going to be on the exam or not, like something like that is going to be useful on the exam. So make sure that you can implement and compile stuff like append to a linked list, insert to a linked list, like what we've just done, delete from a linked list, find the link to the linked list. Those are the common operations on the linked list. And yeah, it's useful to know how to do that. All right. So I think, yeah, so we are at the hour actually. So Q5 is also something that I would consider doing, but we are at the hour and I need to go soon. And I do want to talk to people if they have questions. So Q5 is doable right now. So apart from that, I believe that the only questions that are doable right now from the exam are the dynamic programming question, which is kind of like a more difficult question, and the graph question is kind of doable, but we haven't really. So technically, it's doable, but it's going to be more doable as we do more stuff in class in the next several weeks. Especially if you're struggling, I would say, if you get to a place where you can do, so like everyone should be in a place where they can do like Q1 and Q2, like that's not really negotiable. So, and if you're not there, then yeah, like practice the online exercises, practice the early labs, and that should get you there. I would say so recursion is always more difficult to people. I do not say like if you're struggling, just give up. Absolutely not. So like do the basic recursion examples. Like it's always a bit of problem solving. This one was very analogous to stuff that we actually had done in labs and lectures. So if you just go back and say, oh, this is like STRCMP, and I just remember how STRCMP was done, you could probably kind of transfer most of that to this. So this one, it's a little bit more kind of, there's more stuff there. So there's like struct, so there's like new stuff that's not from Python, but at the same time, it's like extra. So we spent a bunch of time on it, both in lecture and kind of, we did some previous examples from previous years that are like that. This is like always there all over the place. So like if you practice linked lists, this kind of question as well should be gettable. So those are, I think, the ones that I would focus on right now. So Q5, basically it's like another reason I don't really want to do it now is like technically we've done the material, but once you've done project 2, it should be more intuitive to you as well. So not like the dynamic programming aspect of project 2, but like the operating with images. The other ones are not really doable yet because we haven't covered and maybe won't have actually covered the requisite material for the other ones that I had mentioned. Okay, all right. So at this point, what I'll do is I'll stop broadcast. Okay, I won't stop screen sharing. That makes no sense. But I will stop. I'm stopping the live stream, and if you don't know the Zoom link, it's on Discord. It's also like the usual Zoom link that we've used for lectures. So I'm stopping the live stream and I'm stopping the recording. And if someone has kind of questions that are like more individual, but you can still discuss them and feel like it would be useful to discuss them with other people present, I'm happy to answer. Otherwise, it would be kind of more individual by appointment thing. For example, I have office hours Tuesday, 6 p.m. Toronto time, also on Zoom. All right. Okay. Bye, people.